Good day, grade 10s and the grade 11 and 12. Welcome to this session on functions. Okay, we'll be dealing with your exponential function. Please do watch other videos where we've covered the other functions, your parabola, hyperbola, as well as the straight line function. Okay, also watch the session on terminology where we covered the most important terms in functions like your axis of symmetry, asymptote, domain and range, as well as the notations that we find in functions. Now, we are looking at an exponential function. So, how do you see an exponential function? An exponential function is a one-piece function, okay? Unlike the hyperbola, a hyperbola is a two-piece function, but when coming to the exponential function will have only one piece, and also it will have one asymptote, and that asymptote is what we call the horizontal asymptote, okay, which will be given by the equation y equals to q, where q is the value of the horizontal asymptote. So in contrast to the hyperbola, which has two asymptotes, the vertical asymptote and the horizontal asymptote, we are saying the exponential function will only have one asymptote, and that will be the horizontal asymptote. One piece, one asymptote. Okay. Also, your exponential function will have only one x-intercept and will have one y-intercept. Okay. That's very, very important. Then also, the y-intercept of the exponential function will always, this is important, will always be 1 unit more than the value of the horizontal asymptote. Okay, so if your horizontal asymptote is 2, then the y-intercept of the exponential function will be 3. It's always 1 more than the value of the asymptote. Okay, if your horizontal asymptote is y equals to a minus 4, then the y-intercept of the exponential function will be y equals to a minus 3. Okay, remember minus 3 is bigger than minus 4. So the y-intercept in this case will always be bigger than the horizontal asymptote by 1 unit. That is very, very important. Okay, now, like any other function, there will always be a formula or a rule or an equation which defines that particular function. So in this case, the equation that defines the exponential function is y equals to ab to the power of x minus p plus q. Remember, ab, p, q signs may vary, especially with your a, your p, and your q. Okay, the signs will vary. We may get a positive, we may get a negative, so it will depend. But let us quickly look into what each of these variables here stand for. So starting with a, our a determines which side of the asymptote, okay, which side of the asymptote the function lies. So that's the function of a. A tells us which side of the horizontal asymptote the function will be found or will lie in. Okay, so it means we will look into the sign of a. If a is positive, then it will tell us where the function will lie, above or below the horizontal asymptote. If a is negative, also it will tell us whether the function will lie above or below the asymptote. Now let's go to b. What does b stands for? B determines if the function is increasing or decreasing. Remember, where we covered terminology as well as when we were dealing with our straight line function, we've spoken about an increasing function and a decreasing function, where we said if a function is increasing, then that means as the x values are getting bigger, also the y values are getting bigger. Then where a function is decreasing, we are saying as the x values are getting bigger, then the y values are getting smaller. So where x and y do the same thing, then we get an increasing function. Where x and y do the opposite, we get a decreasing function. Okay, so in this case, b for an exponential function determines that. It determines whether a function will increase or the function will decrease. Okay, so it means we'll look into the value of b and it will guide us as to whether a function will be increasing or decreasing. Okay, then we've got that part from the equation which was saying x minus p, or it will be x plus p depending on the sign of p. So what does p stands for in our exponential function? So p stands for the horizontal shifts, okay, whether the function will shift to the right or to the left. All right, and then by how many units? So it will shift to the left by p units and will shift to the right by p units. So if we have x minus p, that means our function will be shifting to the right, because when you solve by equating x minus p to 0, you'll be finding a positive answer, and positive means the shift is to the right. If we have x plus p, p is positive there, then it means the graph will be shifting to the left, because when we solve for x, we'll get a negative value of p. Okay, so p is all about the shifting to the left or to the right by p units. And then we've got the value of q, which may be positive or negative. So what does q does in an exponential function? It is responsible for the vertical shifts up and down. How many units is the graph moving upwards, or how many units is the graph moving downwards? That is q. Q is the one that tells us how many units that will happen. But also, it's very important to note that when you equate your output value, y being equals to q, q on its own, the value of q is our horizontal asymptote. Very, very important. Please note it down. Whenever we start changing q by adding or subtracting units, that's when we get the shifting. But if a question is given and in space of q we've got a value, that particular numerical value is your horizontal asymptote. I hope I'm clear on that one. Okay. Now, having said that, let us go back to each of the variables a, b, p, and q. So about a, what is it that we know about a? We said a determines whether the function will be above or below the horizontal asymptote. So if a is positive, then it means the function will lie above the horizontal asymptote, and that is very simple, okay, where the function will have all positive y values intersecting with the graph. Now, what happens then? It means this is the asymptote, and as we've explained, since a is positive, then the function is above the horizontal asymptote. But also we may have this shape of the exponential function where a is still positive and the graph is above the horizontal asymptote, but just the shape is different, okay? And we will talk about that when we go to b. Well done. Now, let us go to when a is negative. So when a is negative, less than 0, the function will lie below the horizontal asymptote. Okay, so this will be the shape, and we notice that the function is below the horizontal asymptote. Or we may also get this case here where a is also negative and the function is below the horizontal asymptote. The difference are the shapes of the two graphs. Okay, but both of them are below the horizontal asymptote because a is negative. Now, let's come to b. What did we say about b? We said b will tell us whether a function will increase or decrease. So, how do we determine that? If b is not a fraction, okay, if b is not a fraction or a decimal, okay, what's going to happen? Then this is how we write it in math. We say then b will be bigger than 1, but not including 1, okay? And it will not be a fraction, and as a result, the function will be an increasing function, okay? The function is increasing if b is not a fraction. I hope I'm very clear on that one. So you look at the value of b, is it a fraction or not a fraction? Then you can tell whether it is increasing or not. Okay, so what do we mean when we say a function is increasing? We're saying as x values increase, also the y values are increasing. Okay, then in terms of the graphing, this is how the graphs will look like. Okay, so in this case, since the graph is above the horizontal asymptote, it means we can assume that our a is positive, But what I want us to look at is the function of b. So as the x values are getting bigger to the right, then the y values are also getting bigger upwards. Okay, so it's an increasing function because b is not a fraction. Okay, also as the x values here are getting bigger and bigger to the right, what is happening with our y values? They are also increasing upwards. Okay, so in such a case, that's when we say a function is increasing. Then, opposite to that, we are saying if b is a fraction, okay, and this is how we write it in mathematics, b is between 0 and 1. Remember, all numbers between 0 and 1, those will be your fractions or your decimals, okay? So if b is a fraction, then the function, the exponential function, will be a decreasing function, okay? So what are we saying? We are saying as x increases, the x values are increasing, then the y values will be decreasing. Okay, y decreases. That's what we mean. And that will be given by b being a fraction. So when you look into this first function here, as x increases to the right, what happens with the y values? The y values, we see that they are gradually becoming smaller and smaller. So since these functions are doing the opposite, x increasing, y decreasing, then it's a decreasing function. Also, in this case, we may also observe here, as x is increasing towards the right, the values of y. Okay, very, very important. Now, in such a case, then we say the function will be a decreasing function. Now, let us come to the function of q. Q, okay, we said is the horizontal asymptote. So if q is positive, meaning if the horizontal asymptote is positive, then it will lie above the x-axis. Okay, since the value of q, the horizontal asymptote is positive, which will be somewhere there. Okay, somewhere there. Then we are saying the horizontal asymptote will be above the x-axis, and you can see that. But also, if our horizontal asymptote is negative, the value of q is negative, then the horizontal asymptote will lie below the x-axis. Okay, and this is what we'll be getting there. All right, very, very important. So how do we sketch an exponential function? I've written some points for you here that you need to consider and go through before we do the exam questions. Remember, don't forget to watch the video where we'll be covering exam questions, many past exam questions, okay, that are kept aligned. So please do watch the video, okay. Now, these are the steps to sketching an exponential function. Number one, you need to check if the graph will be above or below the horizontal asymptote. Obviously, that means check the value of a. If it's positive, then the graph lies above the asymptote. If a is negative, the graph lies below the asymptote. That's the first thing. Check your a. And then the next one is you must check if the function is increasing or is decreasing. Obviously, that is by checking the value of b. If b is a fraction, what happens? If b is not a fraction, what happens? So in this case, b is not a fraction, and the graph will be an increasing function. Then, if b is a fraction, you see that, then the graph will be a decreasing function. But also, I think it's very important for us to know that if b is not a fraction and the graph is above the that's when it will be. Okay, that's also below the horizontal asymptote, like in this case here, a is negative, then the function will be a decreasing function. Okay, and what I would like you to note is that when you look into these functions here, okay, look into these functions here, where we said if b is not a fraction. These are mirror images of each other. So it means if this function is an increasing function, then also its mirror image, which is this part here, will be an increasing function. And that is also true in this case here, where we said b is a fraction in this case, and this is a decreasing function. Also, its mirror image, okay, will be a decreasing function. So both the mirror images will be decreasing functions, okay, along the line x-axis, okay, along the x-axis. I think that is very clear. Now, next up, number 3, you need to find the y-intercept by letting x be equals to 0. Also find the x-intercept by letting y equals to 0, okay? And then find your horizontal asymptote, which is just you equating y to the value of q, okay? Then you need to substitute any value of x and check what you get for the y value. That will be giving you another point that lies on the function, okay? So that will be a point that lies on the graph, and it will help you to get the correct shape of your graph, okay, by joining the points that you'll be having, okay? Now, very, very important, don't just look at the value of b and say it's increasing or decreasing. Be careful of the index, the exponents, okay? Sometimes the exponents, especially the exponent, the sign of x, okay, may be negative. In that case, don't forget that b will be a fraction in this case, okay, because it will be 1 over b. Or if this is b to the power of minus x plus something, it will also be a fraction, because when we simplify this negative here, then it simplifies to 1 over b to the same exponent, okay? So don't readily or quickly say b is not a fraction and therefore you start working. Also check what is happening here. If your x, the exponent x is negative, then that is most likely to be a fraction, okay? And then also very, very important, when we are dealing with our exponential functions, okay, usually this point here, okay, this point here will usually be a 1, okay, and that will be the y-intercept of the exponential function. So it means the coordinates there will be 0 is to 1, and then also if we look into this function here, this will likely be a 1 where we get 0 is to 1, okay? So that is very, very important for you to master, okay? That will be usually be the y-intercept of the exponential function, where it's increasing and decreasing, okay? Now, next up, we want to look at the domain and the range of the exponential function. And what are we saying? Remember, the domain is all possible x values of a function that are defined for that function, okay? But nicely put, we can say this is where the function starts from the left and where it ends to the right. And for an exponential function, we noticed that the graph starts from negative infinity up to positive infinity, meaning all real numbers are defined for this function, and we just say x is an element of real numbers. But also, if you don't like this way of writing it, we can use this one here, and then x will be an element of negative infinity up to positive infinity. Then the range of the exponential function will be y is greater than q if your graph is above the horizontal asymptote. So what are we saying? We are saying your graph starts at the horizontal asymptote all the way up to a positive y value, which is called positive infinity. But remember, the horizontal asymptote cannot be included because the horizontal asymptote, the graph is undefined there, okay? So we say y is greater than the horizontal asymptote, meaning all values of y that are bigger than the asymptote, not including the asymptote, okay? Then, if you don't like this way of writing, you can just say y is an element of from q up to positive large y value, which is positive infinity. Then if our asymptote is actually, if our range, the function is below the horizontal asymptote, then we're going to say its range will start from negative infinity, which is the very small negative y value, and it ends right at the horizontal asymptote. Okay, that's when we say y is less than the horizontal asymptote, meaning all the possible y values are less than the horizontal asymptote. Okay, or you can simply write it as from negative infinity up to q. Okay, now we have come to the end of the session. I'm encouraging you to watch lesson on exam past papers, okay, where we will be revising a lot of question papers, very important. So we will cover questions that are on linear straight line function, also on parabolic function, and also on hyperbolic function, as well as the exponential function. Okay, that's where we will be covering past exam papers, maybe about 6 or 7 past papers, where we want to check whether all the information that we have shared on this platform really helped a learner to get a distinction. Okay, so take good care of yourself, and don't forget to subscribe at the end of this session, and I'm wishing you all the best. Don't forget to watch the lesson on revision for past papers. Thank you.